In number 7, they're wanting us to calculate the delta G of these two reactions. There are really two parts to this problem. The first part is to calculate delta G once you have the cell potential using Gunphy. So if we have the cell potential, we can calculate delta G. The second part is to actually calculate the cell potential, which I'm going to label E cell. So that part we're going to need to do as well. So let's look at the first part and see what we need to do. Well, if we know the cell potential, we know Faraday's constant. The trickiest part is going to be to find N, which is the number of moles of electrons exchanged here. And there are two ways that you could do it. One is you could take the equation and balance it. Now I know it's already balanced, but if you got rid of those coefficients and you balanced it on your own, that last step where you're about to combine the two reactions together will tell you how many electrons are in it. But that's not the most convenient way to do it. The most convenient way to do it is to just figure out how many electrons there are from the already balanced equation. So I could either use copper or manganese to figure this out, because they should be exchanging the same number of electrons. And I'm going to use copper because, well, just because. It seems easier to me. So you'll notice that each copper is gaining 2 electrons. So if each copper is gaining 2 electrons, and there are 5 of them, that means 10 electrons are exchanged. So N is going to be 10 electrons here. Now you should get the same answer if you try that sort of thinking with manganese. So we know what N is, and I think at this point you should be able to convert your cell potential to delta G if you need to. Now to calculate the E, we're going to need to look up the cell potentials of both half reactions. And you can see that I've written both half reactions down so that I can add them together to get the total cell potential. By the way, before we go on, you notice that I sort of wrote in 10 electrons, and you notice that I also am ignoring the H plus in the water, which remember is okay. You might also wonder, is it true that for the manganese reaction that it's 10 electrons? And it may not seem obvious at first, but remember you need to compare the oxidation state of the manganese. So you need to know what the oxidation number of that manganese is to convince yourself that it's also 10 electrons. Alright, so now we're just essentially going to go look these values up in a cell potential table like this one. Now I can't really scroll mine, so you're going to have to get yours out and look at it. But the idea would be that you'll notice that the green reaction is going from +2 to 0, so it's getting reduced. It's gaining electrons. And the black reaction must be getting oxidized, therefore. And so when we go to look them up in the table, the green reaction is going to be written exactly as it is here without the 5 in front of it. And so we're going to be able to write down that number directly. You remember, we do not multiply by 5. That's really important because that has more to do with current than it does cell potential. It's one of the major differences when we're dealing with cell potentials. We do not multiply by 5. The oxidation one is probably going to be written the other way around in the table. So all we're going to need to do is write down the number but change the sign. And then we can add them up and we should get that cell potential and we'll be done. Remember, do not multiply this one times 2 because that's not required here. Now the last part is to check these boxes. So they want to know which of these reactions are spontaneous, as in they proceed well towards products. And the answer to that is you need to know what the E cell is for each one. Or you could do it based on delta G. Remember that the E cells need to be positive in order to be spontaneous, or the delta G's need to be negative, and you should be able to see it from either value. I wouldn't check neither direction, so these you can rule out unless the value of E cell is 0 and the delta G is 0. If those two were 0, then maybe those would be a choice.